I'm going to go ahead and get started. I'm just going to give you kind of an idea of maybe on my calendar. So if you guys in Ingalls could kind of tell me if you're going to be gone. I know February we have kind of weird schedules because I know we had the day an in-service on the 10th, and I think sometimes present schools are also gone out of school. Kind of check to see if this might work, but we're looking at maybe finishing up chapter 2 towards the end of this week. I'll have a review for you available both in this week. Give me another day or two, and then I'll also have it available for you here. After doing the exam the first exam, I would like to encourage you, make sure you take time to work the review, and that way if you have any questions, because that'll be similar to what will be on the exam. We are looking at having the exam maybe on the 20th, and then I'll start then on the 31st, or 3.1 on the 21st. So anyway, if those days do not work in Ingalls' schedule, kind of let me know so that I can adjust it. So today, we're going to talk about transformations of functions. And the functions, we need to be able to have an idea that if we have a linear, and a lot of our work has been on linear functions. Obviously, if I have an x and a y coordinate system, a linear function is going to be either have a positive slope. It could also have a negative slope. We talked about having no slope and being horizontal, or having an undefined slope and being vertical. But those are going to be the different functions. We've also dealt with absolute value functions. Absolute value functions are going to be ones that always come to a v, but they can also shift from left and right. When we've done quadratic functions, they'll have a U shape. And then the new ones maybe for you guys will be the square root functions. So if I have y equals the square root of x, starts when x is equal to 0, and it's going to go ahead and it's like a half of a parabola going right. Notice the parabola would finish if it would be y equals x squared, and that's when we have root of x and we have just the positive of it. It's going to be then starting here, and it's going to be in this shape. The cubic function is going to be where the ending, when I look at the ending behavior, when x approaches infinity, in other words, it's getting bigger this way, y is also getting bigger. And then notice that it's going to be an odd function, because we talked about odd functions before. In this case, then when x is going to negative infinity, y is also going to be negative infinity. Do you remember covering those maybe last year a little bit?
Yeah.
Okay, and then the cube root function is going to be just this one, and notice it just switches and it's going to turn here. So these are what we've graphed is going to be the parent functions, or when you talk about a parent function of the absolute value, it's just going to be y equals the absolute value of x. If you have a standard quadratic function, it's going to be y equals x squared. Okay, and then if you have the cube run is one. But now we're going to be working on shifts, vertical shifts and horizontal shifts to the function. Now, I would like you to encourage you to make sure you use your Desmos. Desmos is, again, a great way, a tool where you can look and see what the graph looks like, and you can always pull those out and plot those with Desmos. But when I have a function, okay, and in this case, g of x, it says it's going to be f of x is going to be f of x plus 4. So when we start off this, they've graphed f of x, and it looks like just a constant line between -2, and so when I have then plus 4, that means every point on this original line is going to be then shifted up 4. So 1, 2, 3, 4, and then I'm going to put it in yellow. So this one is going to be the g of x is going to be just shifted to going up, and then it will be the same values. And notice on the next one, when we have, and this time I'm going to put it in green, so I have h of x is going to be f of x minus 3. So again, if f of x is the dark colored in the picture, I'm just going to go then down 3 for every point. And this is going to actually remain constant no matter what. If you have any number that's going to be plus c, so it's f of x plus c, no matter what my function originally looked like, if you have a constant that's added to it, it's just going to shift the value up. If you have a function that has a minus c, then it's going to shift it down. Now, on our functions, okay, it says use the transformation of the value f of x equals the absolute value of x. Okay, so this is what's graphed. So when x is equal, remember when we did the t-table with absolute values before on the first section, we had x and we had y, and we picked points for this. So in other words, when x was equal to a -3, we had -2, -1. This was actually on our test. Then we had 0, 1, 2, and 3. And then we plot these values here. When I take the absolute value of -3, I'm going to get 3. Okay, when I add the absolute value of -2, I'm going to get 2. When absolute value of -1 is going to be 1. Of 0, it's going to be 0. And then it's going to continue on that same direction. So that's why it creates that V shape. But then I'm going to go ahead and add g of x. And g of x is going to be a transformation where it's going to be down 7. So every point that I have now down. So I'm going to go 1, here's 5, 6, 7. And so I know I have that same shape of V, just down 7. So it says, what transformations are needed to obtain the graph of g of x from the graph of f of x? And so we're comparing those two and select all that apply. Is it a reflection about the x-axis? In other words, and that would mean that my gray line would just be flipped over. Would that be true? No, because that would look actually like it would just, the reflection would be coming down. Reflection about the y-axis, okay? So in other words, does it look from here to here? And that would not be true either, because that actually this one is reflected about the y-axis because it's the same thing. But this one, but my yellow line didn't affect that. So if I said a horizontal shrink or stretch, now horizontal shrink or stretch is going to be how wide or how skinny it created it. And we're going to have that. We'll have an example of that in just a second. But we do have, in this case, we have to decide whether it's going to be a vertical shift or a horizontal shift. So in this case, a horizontal shift would mean going left or right. But a vertical shift means it's going down. And so this is the one that would apply. Does that make sense? Okay. Vertical stretches or shrinks is going to be then the width of the graph. So let's go ahead. Horizontal shifts. Okay. So horizontal shifts actually fall within the function. Okay. So what happens if I have f of x, okay, which is this line here, if I go plus f of x plus c, which is embedded in the function, that means I'm going to have a horizontal shift. Then it's going to be, in this case, it's going to move to the left. Now, notice that typically, if you go plus c, you're going to go the opposite direction. So to me, I always felt like this, you have to think about it in terms of the opposite. So it's within the function, you're going to, and it says plus c, then you're going to actually think about in terms of what would you add to that, and have to be the negative value on that to make it back to f of x. And so this is going to be to the left. If you have a minus c, then that means you're going to actually go to a shift to the right. So let's do a couple of problems that you have those examples of. So this one is going to be just, if you see, it's kind of a function that's kind of funky, okay? But they're representing this one as f of x. And so in other words, if I'm going to have all my points, and I'm going to go ahead and write out my f of x points, and those are going to be then -4, 0, and then I'm going to have then -2, 0, then I'm going to end up with 0, 0, then I'm going to end up with 2, -2, and my last point would be then 4, 0. So that's my original function. But then I wanted to think about what happens if I have g of x. Now g of x, if I'm going to go x plus 4, remember that for f of x, g of x is going to be the same as the f of x, but it's going to be minus 4. So in other words, it's going to be f of x plus 4. That means that every one of my x values, I'm going to shift, okay, this is going to shift to my x value, and I'm going to shift it the opposite. So if this is going to be a plus 4, then it's really going to be then a minus 4. I'm going to go to the left. So in other words, my new coordinate point is going to look like this, where it's going to be negative 4 minus 4, but my y value doesn't change, so it's going to be 0. I'm going to leave a little more room, sorry. And then that means a negative 4 minus 4 would be then negative 8, comma 0. So I know that this new function of g of x would be coming out over here at negative 8, comma 0. And then I'm going to do the same thing on each of my points. So I start off with a negative 2. I'm going to subtract 4 and 0. So my new point would be then six comma 0. So, oh, you know what? I didn't do that right. So negative 2 comma 2 is be this point. And so you're right. It's going to be then negative 6 comma 2. I've messed up. Okay, so this point now is going to be shifted over to negative 6 comma 2. And then I'm going to end up with 0 comma 0. So my new one, I subtract 4 from it. So I'm going to have negative 0 minus 4 comma 0. Then I'm going to end up with negative 4 comma 0. The next one I'm going to have 2 minus 4. And that's going to be then same y value of negative 2. Negative 2. Okay, so I'm going to have 2 minus 4 would be negative 2, negative 2. And my last one, if I have 4, 0, I'll have 4, 0, and it's 0, 0. And so then I'll go ahead and plot each of those points. So in other words, then I've got the negative 6 comma 2 is already, I've got then negative 4, 1, 2, 3, 4, comma 0. Then I'm going to have this point, which would be the negative 2, comma negative 2. And then I have the 0, 0. And then I would go ahead and just draw my line. Okay, I'm going to go ahead and put h of x in green. And in this case, on h of x, remember we're going to end up doing f of x minus 3. So when you have a minus 3, that's going to move it to the right. In other words, we'll be adding then 3 to it when you move it to the right. So I'm going to start off my f of x, which is still the same points I have. So I would have then negative 4 plus 3 comma 0. Goodness, I keep writing things that I don't need to have. So comma 0. My new point would be then negative 1 comma 0. So in other words, this point right here is now going to be negative 1 comma 0. So I'm going to put that one in green. And then I'm going to move this point, which is negative 2 plus 3 comma, I'm not changing my y value, so it's 2. So this is going to be then 1 comma 2. So I have this point, will then move over 1, 2, 3, and I'll have this point. So in each of my points, I'm going to add 3 to it. And I could go ahead and list each of those points just the same way what I did before, by just adding 3 on this. So on this one, if I'm adding 3, it's going to be 3 comma 0, which I didn't put that point there. This point right here, 1, 2, 3, it's right there. And then the same thing goes on each of them. So it would be 5 comma negative 2, and then the last one would be then 7 comma 0. All right, so when you do these problems, and we will have one similar to this on your test, and then so I would like you to at least identify the points, and then you'll have to tell me the shift, you know, left or right. Okay, so the next one, we're going to use the transformation. We have, in this case, f of x equals the square root of x. And this is going to be a parabola. Okay, and then, so in this case, we want h of x plus 3. So in this case, because it's within the function and not a constant outside, this tells me that it's going to be a shift horizontally. Which direction will you move, left or right?
Right.
Okay.
No.
Left. Yeah, right would be positive. Yeah, so in other words, you're going to go back 3. So it's going to be this one right here with B, and you'll have several points like problems like this on your homework. But then every point like from here, you're going to shift left 3. So this point, which is 0, 0, I'm going to come over 1, 2, 3. Man, my didn't graph very well. But then I'm going to have that same parabola. So this is going to be the same, so it's f of x. So in other words, I'm going to come up 1 over 1, back 1, up 1. And so I'll have then my new parabola. I'll go ahead and put it in my highlighter so it doesn't bleed through. But it'll look a little bit more like this. In other words, it shifts over to the left 3. When we have a reflection about the x-axis, then my original function, say, was f of x, was x squared. Then I'm going to have a negative out in front, okay? And so the negative out in front will indicate that it's just going to be a reflection about the x-axis. So in this case, it says use the graph of f of x, okay, to graph g of x and h of x. So in this case, we're going to start off with this one, where it's going to be, so g of x is going to be a negative f of x. So I know that in this case, if I have the point negative 2, comma 0, and I reflect it back, it's still going to be the same as negative 2, comma 0. But then this value here, when I have the 2, comma 2, when I do the reflection about my y-axis, what changes is the y value. So all of these values here will be the opposite. So if I have 2, comma 2, then I need to make this then negative 2. So then this is going to be my 2 point at 0, wow, did I not, 0, I should have had 0, comma negative 2. Sorry, my mind is not here today. So this point right here is 0, comma negative 2, but I am going to change, or positive 2, so I'm going to make it negative 2. So this is going to be this point. Good Lord. I'm going to have to go get another cup of coffee, I think. So in this point, right now, let's see if I can put it up here. Let me just put it up here where it's 2, comma. So my new point would be then 2, comma negative 4. I'm going to let you answer so I don't mess up again. So then I'm going to go then 2, comma negative 4. And then the same thing with 4, comma 4, comma 4. Now we'll change to 4, comma negative 4. So they have that. And then I have the last one, 6, comma 2. So I have 6, comma 2, which I know is going to change to 6, comma negative 2. Oof. So see if I'm on the struggle bus today. And I'm being recorded, which is awesome. So now, if I have reflection, okay, so in the next one, if I have the reflection about the y-axis, okay, in this case, then on h of x, what's going to change is not my y value, it'll be what? The x value. So in this case, this is going to flip, and so in this case, I'm going to go ahead and mark my points like I did so I don't mess it up this way. So I'm going to go negative 2, comma 0. This is my original one. Then I'll have 0, comma 2. So I know that my original point right here, a negative 2, comma 0, now my x value will change, and it's going to change then to a positive 2, comma 0. Then on the next one, if I have 0, comma 2, the value for 0 doesn't change, and so it's still going to stay 0, comma 2. But then I'll have the point 2, comma 4, and that will change to negative 2 comma 4, right? So in other words, it's going to be back over here, negative 2 comma 4. Then I'll have 4 comma 4, and I will change that one to a negative. So I'll have the point negative 4 comma 4. And then I'll have the point 6 comma 2, which again I'm going to make that a negative 6 comma 2. Negative 6 comma 2. So it would be reflective about the y-axis. Okay. Any questions so far with that? Okay. The next one, use the graph of f of x is equal to the square root of x. So this is what the original function looks like, and then we're going to graph g of x, which is going to be the negative f of x. So in other words, when you substitute, again, it's within, it'd be similar, it's reflective about the y-axis because it resembles that. That means that what transformation is involved, then you know that it's going to be, for every negative, it's going to change to positive, and so it's going to look like this. And so, tell me what the transformation would be.
Like the numbers, or?
Like, what would it be? Describe it. What happened?
Reflection of the y-axis.
Reflection about the y-axis. And again, you can go back to your notes and then notice that this was embedded within. And so remember, if it would have been outside, then it would be reflection about the x-axis. So let me just do this. Let's go ahead and say that we had h of x is equal to a negative square root of x. Then that one would be, I'm going to put it in green. That one's going to be going down. So in other words, you're going to have this one, and now every y value changes. And so it'll be like this. And so this one would be the reflect about the x-axis. And remember, the yellow is reflect y-axis. Okay, any questions so far? All right. On the next one, if you notice my green flipped in, so let me see if I can grab another.